I truly appreciate New England. I was born in New Hampshire. I love the four seasons. I love the change of seasons, the variety. The energy management landscape is always changing as well, and at Schneider Electric, we work hard to be leaders in that space. My name is Ed Muskis. I'm the Site General Manager for Boston One Campus here in Andover, Mass. Boston One Campus houses 4 of our 5 business units for R&D development, so it's extremely important that this building is operational 24/7. So we signed up here to implement a microgrid as a service project, partnering with Duke Energy Renewables and REC Solar. A microgrid is a system that allows us to automate and control distributed energy and determine where we draw our energy from. For example, solar generators, the grid power, and in the future, battery as well. Another innovation was microgrid as a service, the end-to-end solution where, as a customer, I don't worry about financing it, I don't worry about maintaining it. I just gain the benefit of reduced cost and uptime of my facility. For us as a customer, the third benefit was to maintain this building as a living laboratory for the further development of that technology. For example, the Energy Control Center, which allows for the automation and control of the overall system. And EcoStruxure Microgrid Advisor is software and allows us to view the energy generation and consumption of the solar microgrid. I really think Schneider Electric is leading the digital transformation of energy management and automation. We have to do more with less, and the solar and microgrid technology provide customers the opportunity to have a choice of where they get their energy and at the same time to reduce their costs.
Welcome to the Microgrid Lab at the Andover R&D Center of Schneider Electric. We're really glad you're able to visit us today virtually, and we do hope to see you again live at some point in the future when people do that again. So when people come to the Microgrid Lab here in Andover, what we love to share with them is our EcoStruxure microgrid solutions. And you can see in the background here a bit of an EcoStruxure figure to help us guide through this conversation. But before we dive in, let's talk about why would somebody even care about our EcoStruxure microgrid solutions? Well, there's basically 3 reasons. First of all, we have many customers who are very interested in resilience. When power outages are making life difficult, solutions for electrical resilience are absolutely what's needed. Secondly, we have a lot of customers who are very interested in sustainability. And when we're working for more sustainable solutions, microgrids are a great way to do that. Thirdly, a lot of people are looking for cost savings on their electric bills, or at least predictable, manageable costs as you look into the future and not to be surprised by sudden rate increases. So the EcoStruxure microgrid solutions that we offer work to provide these 3 aspects of resilience, sustainability, and cost savings or cost management. And when somebody is looking for all of those, that's the sweet spot. That's where this is very interesting. So a little bit about how it works. We have these 3 different layers in the EcoStruxure stack that are doing completely different things at different time frames. At the bottom level, we have our connected products. Up a level, we have our edge control. And then finally at the top, we have our apps, analytics, and services. So there's many offers in this overall suite that we'll be talking about in more detail. But the overarching theme here is because it takes so much to get a microgrid to work, the enemy is really complexity. And what we're working very hard here at Schneider Electric to do is to alleviate the complexity with the various offers in the EcoStruxure microgrid solutions suite. And by alleviating that complexity, we can overcome the barriers to microgrids being more widespread. So we're going to continue with a demonstration that shows how the edge control and the connected products can work together to provide resilience in the case of an outage. We're now going to dive into a little more detail about how our EcoStruxure architecture can be used for microgrid solution. And in fact, we're going to use the microgrid that we have here at this facility as the example that we go through, like a case study. So as you notice in the EcoStruxure architecture, it all starts on the bottom with the connected products. And there are a lot of different examples of connected products in a microgrid. I'll start with a few that are right here inside the Energy Control Center. So this piece of white electrical equipment next to me is an Energy Control Center, or ECC for short. And it has several different sizes of smart breakers in it, ranging from 150 amps, 250 amps, 600 amps, and 1200 amps. And so that's an example of a connected product that's inside the ECC. But there are many other examples. For instance, uninterruptible power supplies elsewhere in the facility, PV inverters up on the roof, or a lithium-ion battery energy storage system, or a genset just next to the building. All these things are great examples of connected products, and the key thing that makes them connected products is not only do we run the big wires over to the connected product to collect up the power and to allow the high amps to flow through, but we also run the little wires over, and that's where the bits and the bytes are able to flow back and forth so that information can be communicated and control signals can flow. And the white arrows up and down the stack here in the EcoStruxure diagram, that's exactly what they're trying to indicate, is the flow of information up and down the stack. So connected products tend to do a function very fast, sort of in the millisecond time frame, and they tend to do it quite autonomously. So an example of that, again, using the breaker would be if there's a short circuit on the load downstream of the breaker is going to open in tens of milliseconds, and it doesn't need anybody's permission to do that. It's a breaker. That's what circuit breakers do, right? But turns out these smart breakers have little embedded power meters built into them. So they know not only the current, but they know the voltage, and therefore the power, the reactive power, the frequency, the power factor, you name it. All the great information you could pull from a power meter, we can pull from these smart breakers and have that information flow up to other layers of the stack. So the next layer up, edge control, is really all about resiliency. So the offer here that Schneider has, EcoStruxure Microgrid Operation, can work together with the connected products in order to provide resiliency for a site, and it can do that quite quickly, kind of on a second-by-second basis. So for example, if the edge controller found out from one of the breakers that the utility voltage had gone away due to an outage, it could send a command to open the main breaker in the ECC to isolate from that grid that's down, and then it would send a command to start up an anchor resource like a generator or a lithium-ion battery energy storage system. And then it would sequence in the load breakers quite quickly, and within seconds, we've got everything back on that the local resources are able to power. Now, that is how the two bottom layers, edge control and connected products, work together to provide resiliency. But here in the US, luckily, the grid is up over 99% of the time. And so that begs the question of what's the optimal thing to do while the grid is up? And that's where EcoStruxure Microgrid Advisor comes in up at the apps and analytics level. It is looking to optimize the economics of the system to maximize the return on investment from the resources that have been put in at the site. So that's kind of a minute-by-minute type of question, and that's why you see the minute time frame up here on this top level of the EcoStruxure architecture as applied to microgrids. So a good example of that might be if you have a lithium-ion battery energy storage system, on a minute-by-minute basis, we need to decide, should we be charging the battery or discharging the battery? Or just waiting patiently because it's not the right time to do either one. So connected products very quickly do some autonomous function. Edge control in a microgrid is primarily to provide resiliency. And at the apps, analytics, and services level, EcoStruxure Microgrid Advisor provides economic optimization. So now we're going to dig into the case study of this site, the Andover R&D Center of Schneider Electric. And we'll start with kind of a zoomed out look of the building from an electrical point of view. So this is a simplified one-line diagram of our site before we put in the microgrid. And so you can see we have 2 MVA service coming in from the local utility and a lot of 480 volt loads. One very large load, which is a chiller, and that really ties into our peak load for the site. On a very hot summer day, we'll get up to about 1.5 megawatt peak. And that's why we go ahead and give that HVAC load its own special symbol in our simplified one line here. And then in terms of original backup power at the site, we had a very conventional arrangement here with a 400 kilowatt natural gas generator feeding as the alternate source for an automatic transfer switch, the ATS you see here. And either utility power or generator power feeds through the ATS to an uninterruptible power supply, which then feeds the data center and critical loads in the facility. And that way, even if the utility goes down and it takes a few seconds to bring up the generator, the data center and critical loads never even see a blink thanks to the UPS. Okay? Now, one thing you may notice here is 400 kilowatt generator, and we only had 200 kilowatts of data center and critical load. And with this setup, there's no way to use that extra capacity of the generator. That extra 200 kilowatts of capacity it has no path to any of these other loads. So that means all these other loads up on the main distribution board, they all go dark during an outage in our initial setup. So that was one of the main things we were looking to do better at as we implemented a microgrid with some solar resource here at the Andover R&D Center. So let's take a look at what we did. So we put in an energy control center, the piece of equipment I'm standing next to, and we did some analysis of the loads that were going dark during an outage that were the most painful. And we found a couple of very important loads, one of which has a 200-person conference center. So we could have people travel here from all over the world to come to some event in our conference center. And if the power went down and we had them in the dark, we'd just have to send them back to their hotels. And that's not ideal, especially if you traveled from far away. And so that sector of the building is one of the things that we moved over into the ECC to become part of the microgrid. And some other key loads, particularly associated with resiliency plans for shelter in place for a potential winter storm scenario. So we moved these loads into the ECC, and we brought over that otherwise stranded capacity of the generator. So that extra 200 kilowatts that the generator has to give is available to power these additional loads. Furthermore, when we added solar to the site, we connected it into the ECC, and we're in the process of adding a battery to the site, and we'll talk through how that works as well, but that also is connected to the ECC. So when an outage happens, as I'll show in a demo here in a second, the ECC main breaker opens, and the loads in the ECC are served by this combination of the generator, solar if the sun is shining, battery if there's state of charge left in the battery. Okay, so we're going to dive into a little demo here and show how the edge control and the connected products work together to provide resiliency. One last reminder before we do that is don't forget about the 200 kilowatts of critical load that's downstream of the UPS, but it's upstream of the ECC. So when we zoom into the ECC, you won't actually see that load on the ECC, but the generator still feels it. It's still part of what the generator has to address during an outage. So here we go, zooming into the ECC. Okay, we're going to start with this initial condition, and I need to explain one key thing here. Notice the buttons that say simulated outage, simulated PV, simulated load. The issue here is this ECC that I'm standing next to is actually the twin of the other ECC in the main electrical room of this building. So we have two ECCs that are identical functionally. However, the other one has the real utility power, the real solar, the real loads connected to it. And this one is the one that we're able to use for demos, because in the demo, as I open breakers, we'd be leaving hundreds of employees in the dark if we did it with the real ECC. So we established this infrastructure to be able to give this demo without being overly disruptive here at the site. And we're going to keep the simulation quite simple. We'll just start and stop outages. And we can have the solar in one of three simplified positions: sunny, cloudy, nighttime. And the load can be not only moderate, but we'll step it up to heavy at some points. So in this initial condition, you can see our utility is here. It's 480 volts. And it's cloudy day, so our 350 kilowatt array is putting out 190 kilowatts at this particular moment. And that 190 kilowatts coming from the solar array is actually more than the 170 kilowatts of load attached to the ECC. So 20 kilowatts is actually flowing backwards out the main breaker of the ECC and into other parts of the building. So you see that indicated by the negative 20 kilowatts flowing through the main breaker of the ECC. So we're going to go ahead and start a simulated outage here in just a second. And you're going to be able to hear the breakers opening and closing, I think, pretty clearly. Let's go ahead and see what happens. So I'll start the outage now. So you see the utility voltage went to 0. The generator's fired up to 480. 1, 2, 3, breakers click in. That's the generator breaker closing after we gave the generator a few seconds to warm up and stabilize. And then we sequence in the high priority and low priority loads. And so now you see, here we are islanding, and everything is back on despite the utility that's down. And notice that the PV is able to work together with the generator to power these loads. In fact, at this particular point in the demonstration, it's roughly a 50-50 ratio between the PV solar and the generator. Now that's fine and dandy if the sun is shining, but if it's nighttime, now our 400 kilowatt generator is working quite hard. It's all the way up at 370 kilowatts. And notice that our load is still just moderate. So let's take a listen and see what happens if the load were to step up to heavy. Bet you heard that. So that is the lower priority load breaker opening, and that allows the rest of the system to continue to be powered. So the high priority load stays on, that data center that you don't see attached to the ECC, but that data center is still being powered. And so that 200 kilowatts of data center and 180 kilowatts here on the high priority load is why the generator is at 380, but it can't take more than that. And you may have even noticed that the generator for just an instant went above 400 kilowatts, and then the controller opened the low priority breaker. So we'll go ahead and see what happens if the sun were to come out. So as the solar power ramps up, notice that little clicking noise, and the system is smart enough to realize now that we're getting help from the sun, we can go ahead and close in the low priority load. Now, eventually, the utility is going to come back on. So let's go ahead and simulate that and witness how this particular system transitions back. So we'll stop our outage. Notice the utility at 480 volts. So we turn the generator off, open the generator breaker first, and then close the utility breaker in. And here we are back connected to the utility. So this is kind of the end of chapter 1 of the story. And somebody almost always asks me at this point, well, how's this system going to work as soon as you guys finish installing the battery? Well, let me go ahead and show you that now. All right, so I've added a battery to the system, and much of the story will be the same. So we'll go ahead and get started. Let's have an outage. Generator comes on, give it a couple seconds, closing the various breakers, and now we've got everything re-energized except the utility, which is at 0 volts, that we've separated from. And again, this is a great situation when the sun is shining, but if it's nighttime, now the generator's really working hard at 370 kilowatts. So now let's take a listen again and see what happens if the load goes heavy. Notice the silence, right? The breaker has not opened. The extra power is coming from the battery, but notice the state of charge of the battery is falling. And when it gets below 5%, the battery shuts down to protect itself, and the load breaker has to be opened so that we can get back to the situation we were in before. Because without any help able to come from the battery, the generator has to do all the work just like before, and you see the same reaction just as you'd expect. When the sun comes out, we can start charging that battery back up. And at some point, we even have enough power to go ahead and reconnect that lower priority load. And eventually, the outage will end. And very similar to before, we'll transition back to utility power. So to sum that up, I'm going to come back to the high-level view with the EcoStruxure architecture and how we apply it to microgrids, and just recap the key points that the connected products act very fast for some core autonomous function, like for instance a breaker being a safety device. The edge control acts at kind of a second-by-second basis to provide resiliency for the site. And EcoStruxure Microgrid Advisor works on more of a minute-by-minute basis to provide economic optimization for the site.
Hello and welcome. My name is Drew Gravitt, and today we'll be briefly covering EcoStruxure Microgrid Advisor, which is Schneider Electric's cloud-based software platform that optimizes distributed energy resources by tracking, forecasting, and visualizing when we want to consume, produce, store, or sell energy. When the user logs in, they'll start with this page here. They can do that via their laptop, tablet, or smartphone using their cybersecure name and password. What you see here is the real-time page. So we see that the utility is there at the top using 386 kilowatts. We have 3 solar panel arrays. We have a generator, UPS, both of which aren't operational right now, and 2 EV charging clusters. Several other loads such as lighting, and our cooling system is not currently running as it's winter. You can see based on the color of the bubble how much energy is coming from those different resources. So we can see other loads being fully yellow around the circle as using the most energy, a little bit by our electric vehicles, and then as far as generation, only a little bit of our total load is being served by the solar panels as the weather in Boston right now looks very cloudy and probably a lot of snow on the panels. If we come over to the right, we look at the electrical highlights. The grid consumption, our max consumption is a megawatt. We're only using about 387 watts of that, so we're well below our demand charge limit. Our rate is about 15 cents a kilowatt. We're in what we would call mid-peak, the arrow indicating that if we were in a time of use tariff, what the next tariff would be. So if the next tariff was a high tariff, the arrow would be pointing upwards, indicating that we were entering, potentially a 20 cent. If it was pointing downward, the opposite, obviously, the rate would be dropping. Since we're using almost entirely the utility, our emissions are correlated with the utility emission rate at 262. Below we have weather information here for the next 3 hours. Looks like about 35 degrees in Boston, significant cloud coverage, a little bit of wind, and the probability of a storm is still pretty low. If the storm probability increases, we can go to a 2, and if it's a very severe storm approaching, then we would have a 3, and we might operate the microgrid a little differently. Again, we're looking at a real-time view. We could look at a different day. We could look at how much energy we've consumed today, yesterday, this week, last week. We could personalize it. If we just did last week, we enter into a new view here where we can see for the utility, we used a certain amount of megawatt hours. We generated so many megawatt hours of solar. The generator ran a little bit. Our electric vehicles consumed this amount, and so on and so forth. Our monthly savings over here and costs. So our last year costs were around $20,000. This year we used less, so by about $3,000. Our savings were also a little bit more this year. So through the use of solar and other distributed energy resources, we saved a little bit more money at our microgrid this year. We have information about our carbon footprint here, so our CO2 emissions, the savings from our solar, and then the adjusted emissions, so total emissions from the site. And then we have a chart showing a wheel showing us the different ratios of what we use. So over this period, we use mostly imported about 96% of our energy. 3% of what we used was from solar. And 100% was pretty much the other loads, as our HVAC system wasn't really running. If we go back to real time, we can look at our time series data. So a view of the next 24 hours, looking at our forecasts and our expected generation. Up top is our rates here. So we're, again, a flat rate here at about 15 cents. On the next line, we have our demand charge limit is the dotted line, that megawatt that we spoke about earlier. You can see the black was our site forecast versus our actual. So we forecasted about 355 kilowatts. We actually used 371 for the total site. The utility gave us about 371.5 of those kilowatts. So again, most of our energy coming from the utility, and our demand charge limit there shown again as a megawatt. As we come down here, this shows us again our production forecast for our solar was about half a kilowatt or so. So not much coming from there. We forecasted correctly, and our storage, our UPS not being used. The forecast here for the rest of the evening looks pretty small as well. And these are our site consumption forecasts. CO2 emissions, same thing, maintain pretty steady, as we're not expecting to generate much energy from our solar panels. If we continue to move over here, we look at our distributed energy resources, a detailed view again in real time of all of our different loads and generation. If we come down to our carport or our other loads here, we can actually see time series data. So we can see what happened here over the last 4 hours and the future 24 hours, what we're expecting from our other loads, obviously our rate and the power consumed. Here we can also select periods. If we did last week, for instance, we could see, what happened with our electric vehicles. We can also see down here where we were before, our other loads, all of our load profile for the last week, Saturday and Sunday, obviously operating a little bit differently. If we move to our data export, if we go back to our Boston 1, we can see here we have different variables that we can select. We can do our forecasted tariff, our real-time tariff, our emissions, our savings from the different use cases, demand charge savings, tariff management savings, our consumption costs. All these are available for us to export. So you could take a couple of these here, and then you could also pull individual DER variables such as electric power and electric energy for the electric vehicle. You could do that as well for the solar panels. Add those resources. You see them pop up down here. You can select a period, again, let's say last week, and then we can export the data as you can see, it's coming in here. And then we can download the files as they show up right here. Next, you're able to configure the site. So the user has the ability to go into the site and make changes to some of the data that's used to display and considered in the algorithms. So things like the utility emission rate, in this case, the generator emission rate, you can enter those yourself and submit. You can also choose how to set up your tariff. So you can configure your tariff, your winter and your summer tariff. You can change the name, you can pick the duration. So if you have a variable tariff, again, where you have rates that rise or go down depending on the hours of the day, this allows you to input that in if those tariffs change on you. So for weekdays, we can select the different days of the week: Monday, Tuesday, Wednesday, Thursday, Friday. We can choose the cost for energy for on-peak, mid-peak, or off-peak. And then we can actually select the hours that we expect those to happen. So we might have a mid tariff here for these hours, and then our off peak might look something more like this. So in the morning, maybe that's when our utility has the most expensive energy, and in the night and the afternoons, we can imagine it might be lower energy. We could also imagine having some special dates where we might have to configure a specific tariff for those days where it's a holiday or something like that, and then you could submit all that there. You can also change the building name, so you can change the individual DER resource names and the maximum electrical power that you expect from each one of those. So lots of configuration that can be done by the user to customize the EMA how they want it, and make sure that it's always up to date with the latest information. That concludes the tour of EcoStruxure Microgrid Advisor. If you have any questions, please reach out to Schneider Electric to help give you a live demo of this. And thank you so much for your time.